In today's notes, we're going to be solving for a missing side, and we're going to be doing it from both of the angles in a right triangle. So our steps are to determine which angle you are using. So in this first example, we're going to use angle 28 because that is the angle that is given. Then we're going to do it from angle I, which is going to be whatever the difference of 90, 28, and 180 is. So for angle 28, if we want to find the missing sides, we'll call this missing side IH and this one IG. We can solve this in a few ways. So we notice that if we're using angle 28, this is our adjacent side, this is our opposite side, and this is our hypotenuse. If we wanted to use sine, we don't have enough information because it's opposite over hypotenuse. We don't have either of those numbers. So we have to start with cosine or tangent, because cosine, remember, cosine uses adjacent and tangent uses adjacent. So we could do cosine of 28 equals 12.2 over IG, or we could do tangent of 28 equals, tangent is OA, IH over 12.2. Either way, we should get the exact same answer. So if we were to solve this, we would multiply by IG on both sides. Those would cancel, giving us IG equals, 12.2 equals IG cosine 28. We would then divide by cosine of 28 on both sides, giving us IG equals 12.2 divided by cosine of 28. We're going to solve this one next, and then we'll put both in the calculator to see what we get. So tangent of 28 equals IH over 12.2. So in this case, we'll multiply by the denominator again like we did before, but this time it is a number. Those cancel, and that leaves us with IH equals 12.2 tangent of 28. So in this case, we have solved for IH, which is the hypotenuse, and in this case, we have solved for the opposite side. So if we put IG into the calculator, we're going to get 12.2 divided by, second draw, cosine is 3, cosine of 28, that gives us 13.8. So that means we're going to get 13.8 for our hypotenuse. And then for our short leg, 12.2 tangent of 28 tangent is 5, 6.5, the 8 rounds the 4 up. So we got 6.5. So it's 13.8 and 6.5. Right now this makes sense to me. Our hypotenuse is 13.8. That's the longest length, as it should be. Our long leg is 12.2. Our short leg is 6.5. So right now the numbers look like they make sense to me. Now let's see if we could solve this differently. So if we wanted to solve instead from the other acute angle, I, we would find that 180 minus 90 minus 28 gives us 62. So the other angle in this triangle is 62 degrees. So let's see if we get the same numbers using this angle. So we're going to pretend that we don't have the short leg and the hypotenuse, so we're finding them again. So right now all we have is 12.2. That means we could do sine of 62, because sine is opposite, right? So now, if we're using 62, this side becomes opposite, this side becomes adjacent, and hypotenuse stays the same. Notice that if we're at 62, adjacent becomes opposite, opposite becomes adjacent. So as soon as you go from this acute angle to the other acute angle, adjacent and opposite switch. So sine of 62 is going to be 12.2 over IG, and that's our hypotenuse. So we would solve and eventually get IG equals 12.2 divided by sine of 62. So 12.2 divided by sine of 62 gives us 13.8. What do you know? That is the same number we already have for the hypotenuse. So we know that we are correct. IG equals 13.8. I'll just put a check mark here, meaning we got the same answer. If we wanted to use or find the short leg, we could use cosine or tangent because they both incorporate adjacent. I'm going to use cosine. So cosine of 62 equals IH over 13.8. Actually, you know what? Let's use tangent. I'm sorry. We're going to use tangent because I want to continue using 12.2 and not using the side that I just found, and that is because I've rounded this. Because I've rounded 13.8, it makes it less accurate. So I want to use the side that I keep referencing or I keep using. So if we did tangent of 62, we would then get 12.2 over IH. 12.2 over IH, which means that would eventually become IH equals 12.2 divided by tan of 62. So 12.2 divided by tan of 62, and we get 6.5, which is what we already got. So it doesn't matter which angle you're using. You could use 28 or 62, one of the two acute angles. You're still going to get the same numbers. In our next problem, we are going to be finding the missing side length of the triangle, which is this, right? What is this side? Well, this is a 95-degree angle. That means this is not a right triangle. I cannot use trigonometry or sine, cosine, and tangent to solve this. So what I'm going to do instead is create two right triangles by drawing an altitude. This is called an altitude. An altitude is any line that can be drawn to reference the height of the triangle, and the altitude should create two right angles because it's going to go from an angle directly down to create two right angles. So at this point, we can now figure out what the missing side length of this is, and this is. So what is this? And what is this? We'll call this one x and this one y. Then we can add them together to find the entire length of this triangle. So that's what the altitude helps us do. So if we wanted to figure out what this angle was and this angle was, we would take 35 and 90 and subtract 180. So 180 minus 35 minus 90 gives me 55. So this angle is 55 degrees. And if that's 55, the original angle was 95, then this has to be 40 because 40 plus 55 is 90. So now we have a lot of different ways we can solve. I'm just going to choose whatever seems the fastest. So if I want to find this length using this angle, that's adjacent to this angle, so I'm going to use cosine. Cosine of 35 is equal to x over 100, which in other words will be x is equal to 100 cosine 35. So 100 cosine 35 gives me 81.9. So x is equal to 81.9. Okay, that's one length. We still need the other so that we can add them. I'm going to use 50 degrees, and I'm going to use cosine again. So we have cosine of 50 degrees is equal to y over, our hypotenuse is 74.875, which after we solve would become 74.875 cosine of 50. In both of these cases, I'm multiplying by the denominator. That's how I get what I do down here, so multiply by 74.875. That's how I'm getting y equals this times this. So I put this in my calculator. We have 74.875 cosine of 50, and that gives us 48.1. So y equals 48.1. My last step is we are trying to find the whole missing side, so we're going to add these two numbers together. Second answer plus 81.9, and that gives me 130. So our final answer is going to be 48.1 plus 81.9, which equals 130. So again, if you want to find the missing side of a non-right triangle, create two right triangles, find their missing lengths, add them together, and you find the missing side.